Alrighty then, welcome to the Daily Space Weather. We've got another solar polar vortex happening here. Several CMEs going on in the past 24 hours. A new massive pair of sunspots rising in the southeastern limb. Not to mention, huge coronal hole forming there as the south solar polar field leaves the south solar heliographic polar region. Let's do it. And thanks for tuning into the Smash News Network, least busted name in news. So you may see several different filamentary eruptions happening there. This crown prominence led to one. There's one from here, there's one from down here, and at least one from over here. So lots of stuff going on despite a low sunspot number. Another prime example of how we don't need to see sunspots or even solar flares to see coronal mass ejections. Now, there's some missing data there. We'll talk about that later in the video when we talk about the likely trajectories of those several coronal mass ejection events from the past 24 hours. Here's just the northern hemisphere. And here is the southwestern limb where one of those coronal mass ejections did come from. You may see that filament ejection happening right there. And of course, the real place to keep an eye on, and when I say eye on, pardon the pun, is the southeastern limb. There's not just one sunspot group there, but at least two probably. And I suspect the second one is also beta gamma class, maybe even beta gamma delta class. It is actually at an even higher latitude, meaning farther from the equator than this massive sunspot right here. So that's always interesting. Let's take a look at the SDO intensity gram to give you a brief peek at that. Don't worry, we've got close-up images of it in both magnetogram and SDO continuum. So there's your SDO intensity gram. And here is your colorized magnetogram. Again, we got a low sunspot number, but it's going to be coming up here rapidly as we've got some truly massive sunspot groups rising in the southeast. Let's take a brief step away from space weather here for a minute and look at some geophysics stuff. Mount Abico is still exploding. It's producing a 10,000-foot plume of volcanic ash there at Paramushir Island. Abico, flight level 100 over Paramushir Island. Sakurajima, flight level 070 over Kyushu, Japan. Suwanosejima in the Ryukyu Islands exploding, flight level 050 from Suwanosejima. Karengatang, 6,000-foot ash plume, flight level 060 as Karengatang explodes. It's located in the Indonesian island of Siau. Krakatau, producing a 2,000-foot plume of volcanic ash there. Flight level 020 over Krakatau. Please do not attempt to pole vault. The caldera Semaru exploding, flight level 140. It's a 14,000-foot ash plume. Popocatépetl exploding in central Mexico. That's a 27,000-foot ash plume. That's one of the more significant size ash plumes produced by Popocatépetl ever covered on the channel. Fuego is a flight level 145, a 14,500-foot plume of volcanic ash there exploding out of Fuego in Guatemala. In Colombia, Nevado de Ruiz exploding, flight level 230. Sangay exploding in Ecuador, flight level 200. Revenador exploding in Ecuador, flight level 150. And Sabancaya down in Peru continues to explode, flight level 240. It's a 24,000-foot ash plume. Please do not fly your hang glider over the caldera. Next, looking at global seismicity here. And no major quakes over the past 24 hours, but we should say it is an earthquake watch. We've got an earthquake watch in effect, folks, and it is because lots and lots of smaller quakes here around the southwestern portion of the Pacific. So you see all those quakes there? One or more of those quakes could be foreshocks. That is a lot of quakes. So if you're located in that area, please be aware of this, as any earthquake can be a foreshock. So we're going to go over those of a 5 magnitude or greater, like this 5.3 at New Zealand. That came in at 15:46 yesterday afternoon, Universal Time. And then about 25 minutes later, we had a 5.0 at the Philippines. That was at 16:11 yesterday afternoon, Universal Time. And thanks for leaving a comment, Mike Bordages. Kermadec Islands region had a 5.0. That's northeast of New Zealand, in between New Zealand and Tonga, adjacent to the Kermadec Trench. So yeah, lots of quakes there in the southwestern Pacific. And let's get back to space. So here is our 24-hour video. By the way, the videos we started out the coverage with were, those were all 24-hour videos. This is also a 24-hour video. Here we're showing 335 plus 171 angstroms. It highlights the middle and lower coronas. So it creates some great character as to the activity that's going on there. And let's continue on here. The 10.7 centimeter radio flux only at 134 solar flux units. So the 10.7 is super important. It was discovered by Canadians in 1947. They were playing around with some World War II radio equipment, and they discovered that there is a second feature that can be used to monitor solar activity, the 10.7 centimeter radio flux. Depicted here in this black line, that is a one-year graph. 134 solar flux units is the current 10.7 centimeter radio flux number. So there's your space weather enthusiast dashboard. NOAA not forecasting any geomagnetic storms or geomagnetic unrest conditions. We'll talk about those most recent coronal mass ejections here a little bit later in the video. It may be too early for NOAA to forecast any if they are earthly directed, so make sure you stay tuned for our coverage of those CMEs and their likely trajectories. Here we're looking at Earth's magnetic moment from space out to about 12 Earth diameters. The units depicted here are nanopascals magnetohydrodynamic pressure. And you can see most of the pressure there in the magnetotail side, suggesting a recent waning in the past few hours of the solar wind as it tries to reach static equilibrium. Here is our ground magnetic perturbations map, Earth's magnetic moment from the ground level. The units here are nanotesla magnetic flux density. And yeah, there's the last 4 hours of what's been going on planet Earth. Geomagnetically calm conditions are the story. So there is your KP index. That's an average of earthly geomagnetism. Current conditions are 2.33. For the planetary K index, often referred to as the KP index. And let's take a look at the real-time solar wind measured out here at Lagrangian point 1. The gravitational equilibrium point orbited by the ACE and Discover spacecraft. Also, the SOHO spacecraft is out there, and others. Anyway, here is the current situation. Solar wind speed, 408 kilometers per second. Solar wind density, quite diffuse here at just under 3.5 protons per cubic centimeter. Something like 1/quadrillionth of Earth's sea level protonic density. Anyway, here is our GOES magnetometer, and nothing too exciting going on there. A fairly normal operating range there for the GOES 16 and GOES 18 magnetometers. And let's take a look at the heliospheric current sheet, as this is an important one. And let's see. So there is a South Pole current sheet headed this way. You can see these depicted in red for south and green for north. Earth looks like it will soon leave the North Pole current sheet. However, there could be delays here based on sunspot activity. So this does give us some predictive value, although we do have a possible active region rising in the northeast, which we'll get to here when we cover sunspots and solar flares. That's our top view ecliptic plane field plot. Earth is about to move to a South Pole current sheet. Here's our line of sight field plot. And you can see that South Pole current sheet peeking around from the southeastern limb there, which brings us to coronal holes. So here's our coronal hole line of sight plot. We've got some fantastic footage here in 211 angstroms for you. There is our Gong 2 data, which is, by the way, part of the National Sunspot Observatory. Those data are based on 51 ground-based magnetometers and magnetometers on stereo A and stereo B. Here's the SDO 24-hour video. Very well-defined coronal hole there. It just left the south solar polar region. So it kind of just moved from down here up to this area in the past few days. We showed it a couple days ago on the channel. And you may even be able to see that migrate here because this does depict 4 days. So you can see that coronal hole moving there, leaving the heliographic south polar region and now ending up here. Also, I would remind our viewers, if you're new to the channel, you may not know that these are actually solar radio jets. There are high-speed solar protons coming out of those coronal holes. And they're a very important feature of solar cycle analysis. Let's take a close-up. And what you're seeing there is, this is a particular species of ionized iron. That's 211 angstroms. And for some reason, certain species of nuclei don't want to be in this area. All right, so certain atomic species don't want to be around here for whatever reason. And 211 angstroms is one of those species. So over here, you're seeing a lot of this species of ionized iron. Down here, you're seeing very low amounts of that species of ionized iron. And perhaps coronal holes do give us insight into the mechanism underlying the solar cycles. I would tend to think so. And we'll get to sunspots here next. Before we do that, take a look at our featured product. Today's featured product is Do the Math. Because, well, I used to be a computer science major. When I first graduated high school, my college major was computer information science with a mathematics as opposed to a business background. And I got out of there because I didn't want to spend 35 years copy-pasting C++ code. So I decided I needed to pursue some different things like, well, I eventually ended up as a general science major, and then I eventually ended up as a pro cyclist, and I said, I saw the writing on the wall back in the mid-1990s. In other words, I did the math, and I didn't like the looks of things at the time, so I got out of there. Anyway, now I'm back because I realized that there was a hole, not a coronal hole, a hole in cosmology created by a lack of understanding of the sun. Of course, they just gloss over what the sun is all about in a Intro to Astronomy college class. They just say, hey, it's just a ball of plasma. Nothing to see here, folks. It's just a ball of plasma with a nuclear fusion dynamo in the core, and it's internally powered and so on. It's very interesting. And so, anyway, that image there does actually create an anniversary for the date that we released it. It was on February 24th with the high-res, very high-res SDO image, by the way. That's 5,000 by 5,000 pixels, that image. If you visit the links below the video, you'll find our merch shop in order of best selling. Of course, do not pole vault the caldera is one of our channel taglines. We've been saying it for years. And that's because, well, some people are so dumb they have to be told not to pole vault an active volcanic caldera. Anyway, some of our merch is pretty serious. Some of our merch is pretty hilarious. And let's get to sunspots and stop talking merch. So, yeah, sunspots. 3256 is huge, and we're likely to have a second one getting a name. 3257 just rose to its southeast. Yeah, it's at an even higher latitude. So you may be surprised at how high of a latitude that is. The next one is at an even higher latitude, meaning farther from the equator. And let's take a look. So here's that's your SDO intensity gram, SDO continuum rather, for the past 24. We've also got, what the heck, we've also got, we've got a zoom in here with also 94 angstroms included there. And let's take a close-up look at that new sunspot known as 3256 and the new 3257. So there's 3256, and then right there, another at least beta gamma class sunspot group rising there, 3257. I suspect it's beta gamma delta class. We've got quite a bit of activity happening there. We've also brought up the SDO magnetogram. There is some field complexity there. There is a trailing North Pole umbra behind 3256, and likely a trailing North Pole umbra behind 3257. So expect that one to get a name today. You can expect a significant uptick in the sunspot number in the next 24 to 36 hours as those sunspots get added to the sunspot number. Next, looking at energetic particles here, and the proton flux is a little bit off of the baseline there, but no major spikes. That's a subsiding of an event that started back on March 13th. So still some protons there circling, you could say orbiting, Earth's magnetic field lines. And looking at flares, we did see a nearly M-class flare happen here just earlier this morning. And there was a definite M-class flare, quite a long duration C to M-class event happening midday yesterday. Kicking off right around noontime and finally subsiding by about 4:30 Universal Time. Let's take a look at one of the good wavelengths through which to view solar flares, 131 angstroms, which, by the way, is part of the extreme ultraviolet light spectrum. That's the past 24 hours. And how about if we add 171 angstroms to give it a little bit additional character? What do you say? There's 171 plus 131 angstroms. Those are both species of ionized iron also. And how about a close-up? Perhaps it's time for what we'll call the money shot. So, not a lot going on the major portion of the Earth-facing solar disk. Most of the activity down there in the southeastern limb. There is some pretty berserk imagery of that. And let's continue on here and orient ourselves a little bit to what's going on overhead. So we're always interested in what's happening overhead here at the Smash News Network, least busted name in news. Here is the latest from skyandtelescope.org. And we put a box over Altair here because the summer triangle is forming overhead right now. You've got Altair, Vega, and Deneb. That is the summer triangle. If you're interested in such things, I try not to memorize constellations as it is basically completely arbitrary. Certain things I try to memorize and certain things I don't. Trying to save space in the brain, which is surprisingly like a hard drive, by the way. Anyway, here's your solar system forecast. This is where things are now. Let's advance this 1 week. That's where things will be in 7 days on March 25th. And let's move to coronagraphs. So here are yesterday's coronagraphs from George Mason University. If any of those CMEs have an Earth-directed component, it's this one from the southeastern limb. This one down here, right about here. That one there could have a small Earth-directed component, although I suspect not. Lots of frames there from yesterday, 161 frames. And you can see multiple events happening. So you have that southwestern one. You have a northeastern one, an eastern one, and then an additional eastern one. So those are yesterday's frames. Here are today's frames. And you can see the aftermath of that southeastern CME. That CME has some very, very dense components there. You can see how very high density material there showing up on the coronagraph. So, I mean, hopefully it has an Earth-directed component because I want to take more films of aurora here in Lehigh Valley, Pennsylvania. Let's take a look at some more imagery here from Stereo A and Soho Lasco C3. While we're looking at coronagraphs, keep in mind these are not synced and they are not... Well, the Soho Lasco C3's got a bunch of missing data, it looks like. And Stereo A... All right, let's see if we can... Let's move this around a bit. So yeah, a bunch of missing data there from Soho Lasco C3. Let's bring stereo A back to that point. So there's yesterday at 2154. And some missing data from stereo A also. So that one could have an Earth-directed component. If so, it'll be minor, as most of the material is certainly off to the south and west. Keep in mind also that Earth does move in this direction with respect to the sun. So, in other words, a CME that's a little bit off to the west is more likely to hit Earth than a CME that's a little bit off to the east, because Earth is moving away from CMEs that come off to the east. Anyway, here are some 24-hour videos, and you'll see that missing data there in the Soho-Lasco C3. It looks like it's mostly there for the Soho-Lasco C2. So let's zoom in a little bit closer here. That's Mercury, by the way, sliding across. Very dense material there coming out of that CME. So, and it's a long duration CME too. There's a lot of material coming out. It's really a double event there. But they look like they're from the same location and about the same trajectory. So hoping for a CME impact. And if you're frightened of CME impacts, well, I won't give you any advice. CME impacts, not particularly scary. Space, not particularly scary. And the sun, almost 100% unlikely to kill you, although terrible decisions by humans might. So that's the past 24 hours. That's some great imagery there for you from Soho-Lasco C2 and SDO 304 angstroms wavelength. Next, let's talk filaments, as they represent potential future coronal mass ejection. Here's what's going on from the ground-based solar observatory at El Teide, Spain. And first of all, you'll see this crown prominence go blasting off. See, here it is. Oh, then now it's gone. And you'll see this huge filament down here making its way. Bye-bye. You can see some CMEs happening over here and over here. So it was a pretty exciting day for coronal mass ejections yesterday and into today. We still do have a high potential for additional coronal mass ejections. Let's bring up the latest image here. A very large filament up here. It's very, very lengthy. You can see it's stretching all the way around the limb. That one should get a name. And so you're invited to name that filament. Just join us over on Twitter and follow the hashtag #NameThatFilament. And make sure you follow the hashtag SpaceWeather and SpaceWX. So this filament up here needs a name. If you want to name it, just join us over there. Don't attempt to name it in the YouTube comments, because that won't work. If you don't have a Twitter account, you'll need to make one in order to name that filament. And of course, we did cover these filaments yesterday on the Twitch channel. Check it out. Here is the Northern Crown Prominence. You have this massive filament. And you can see some material splashing back down there as well. Yesterday's Twitch stream was like 16 hours long, so maybe install the Twitch app. It'll actually notify you when we go live, unlike certain live streaming platforms, quote, platforms, end quote. Remember, folks, a gallows is also a type of platform. All right, continuing on here, just going to show some additional data as we've got this crown prominence ejecting, and it's making its way to the opposite side of the sun there. It might have even splashed back down, but I think some of the material did eject, and you're also seeing a lunar eclipse of the GOES 16 SUVI happening there. There you can see that filament. It does make sort of a solar polar vortex kind of a thing, and then you can see some activity up here. So lots of stuff to cover for sure. Again, make sure you follow us over on Twitter. We're all over the internet at Smash-O-Mash. You can also find the link to the Hemp Lucid Mushroom Gummies giveaway. It's pinned to our Twitter profile, so check that out if you haven't tried the mushroom gummies. You can still get some free samples. They are still offered. You will have to pay shipping on it. And if you're interested in Hemp Lucid products, make sure you enter the promo code SMASH-O-MASH to save some dough on checkout. Visit the link below the video or on the homepage at smashomash.com, and welcome to the Neo Renaissance. Save some dough on your Hemp Lucid purchase by using our promo code and or our link. Here's the past 24 hours SDO 304 angstroms ionized helium. And check it out, this coronal hole right here is so well defined that even helium doesn't want to hang out around that one. This one down here, not quite as well defined, but quite gaping and quite huge. The gaping maw of a coronal hole. It's like a solar low pressure zone. And solar low pressure zones are so low that they blast material out at like 1,000 kilometers per second. It's a little bit lower pressure, relatively speaking, than a low pressure on Earth, which might cause a hurricane. Anyway, that's the past 24 hours in ionized helium. Here's the past about 2.5 hours in ionized helium from a different object. That's the GOES 16 SUVI. And there is indeed a CME propagating as we stream the video. So we may have to make another video about that, but I suspect not. Some of that material on its way back down toward the chromosphere also. And a huge filament down here as well. Another one that could perhaps get a name, right? This one right here could get a name, and of course name this filament. We name filaments after living people on the channel. And let's get to our bonus features segment. So here is our satellite charging hazards map. Some minor surface charging hazards here over the Central Pacific. Those are minor of the surface charging variety caused by low energy electrons on the outside of spacecraft. Here is our GOES electron flux, and we are expecting an uptick coming in the next couple of days for this. I think NOAA is underestimating. I think tomorrow the electron flux is going to be like up here instead. Make sure you tune into tomorrow's daily space weather video to see if my forecast was correct. Next, the 1-year graph of the relativistic electrons. Those are measured by the GOES 16 and GOES 18. From their geosynchronous near equatorial orbits, they measure the electron flux at the F layer of the ionosphere, which we'll show next. So this is the one slice of the atmosphere, the upper thermosphere, the F layer. Could be considered the bridge between Earth and space, and here's the vibrational frequency of the extremely diffuse gas in that portion of the atmosphere. So the anomalies are not as extreme as the past few days. We did cover some extreme ionospheric anomalies, to the point where some made it onto our thumbnails. Fun fact, our channel's thumbnails contain more information that is relevant to reality than entire channel's content. So that's the vibrational frequency. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. What's cool about this is that it shows the anomaly down to 1/10 of a megahertz. In other words, it shows 10 times the resolution of the raw vibrational frequency data. It's courtesy of the Australian Government Bureau of Meteorology. Things aren't looking too out of the ordinary here on the ionosphere. As we do most days, we'll bring up the latest image after that plays through one more time. Here's today. And there's the latest image. That's 12:30 Universal Time ionogram and 12:30 Universal Time anomalygram. Some high-frequency anomalies happening in the Southern Atlantic, Southern Africa, and South America. Next, the total electron content forecast, and we've actually brought up 2 new tabs today. So we're going to start perhaps covering, let us know what you think, North American viewers. We're going to start covering some additional information about total electron content. It's the free electrons up to about 12,500 miles of altitude. So your GPS satellite must communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And when there are a lot of free electrons there, it causes signal refraction. And things are actually quite orderly here. So most of the high electron regions are right over the equator around noontime, the hours around noontime. And here are some more images here. So we're going to show the total electron content anomaly over just the US. So there's just the US, and you can see some significant high electron anomalies there happening in the Eastern Pacific. And here's a little bit more showing a portion of the Pacific there. The full 50 states of ALSA, the allegedly United States of America. So that's what's going on. Some significant electron anomalies there, and let us know in the comments if you think we ought to keep those or only show the global view. Next, a very high resolution set of images, and the most important area to watch. So there's a flare watch and an earthquake watch at the moment. And that sunspot down there is, well, it's actually two groups, 3256 and 3257. This one might even get its own name, but I think this is going to be considered 3256, and this is going to be considered 3257. Now, at the moment, okay, we've got a South Pole umbra here and a North Pole umbra there. So it's official. Sunspot 3257 is already beta gamma class. And this group here is beta gamma delta class. So very high likelihood of large flares from that portion of the sun. Keep an eye on the southeastern limb. We'll be streaming it today. And if we see any major events, we may have to produce another video. Also, a quick reminder, we will be streaming live for the equinox, as most equinoxes and solstices do feature a YouTube live stream from the channel. So make sure you tune into that. It'll start at about 5 p.m. Eastern Time on Monday. So it's your final weekend. Your final weekend of winter. Or if you're in the Southern Hemisphere, it's your final weekend of summer. So hopefully things are going well for you. So make sure you join us for that. We want to be the first channel on YouTube to wish you a happy spring or a happy fall. Shout out to our viewers from Unda and from Ova, the equator. If you want to support the channel, visit our links, smashomash.com, and welcome to the Neo Renaissance. Again, you can find the Hemp Lucid link there, links to Twitter, links to Instagram. If you want to be motivated to go out and get after it, right? If you want to get after it and have some motivation about getting your workouts in and so forth, join us over on Instagram. If you haven't seen yesterday's videos, check those out. There's a view of our insane corned beef crock pot dish, and wow, it was berserk. So we do produce content besides space, weather, and science videos. We make how-to and lifestyle videos, videos about news and politics, and lots more. Welcome to the Neo Renaissance. Smashomash.com is the homepage. If you want to support the channel, become a member of the Smash team, especially at the gold or silver level. The best value is the gold annual paid-up subscription. It's including complimentary merch. It's almost like getting 4 months of a gold membership for free. And we've explained the plausible mechanism underlying the solar cycles to our gold members as we are seeking funding to write our paper, as I've got a particle physicist from Belarus that I have to pay. And, people don't work for free. It's kind of expensive to write science papers, as we have to not die in the meantime. We have to do stuff like pay for groceries, rent, and electric bills. So help us out by becoming a member of the Smash team if you want to contribute to, it's just the writing of the, one of the most important science papers in hundreds of years, because if we do pass peer review, and we will be explaining the likely mechanism that underlies the solar polar field reversal and hence the sunspot cycles, because the one drives the other, in our opinion. Smashomash.com/smash team is where you can support the channel. Thanks to everybody who has. There's also a bronze level, and we do send out email alerts, by the way. And let's move to meteorology. Check it out. We've got barely above freezing temperatures here deep into Mexico. 33.9 degrees Fahrenheit down there. And there is snow coming to large portions of Mexico. I know it sounds crazy. Let's take a brief look at the rest of the planet here. That is, by the way, surface temperature. And it's still winter in the northern hemisphere, but it's not that cold. Only negative 40 degrees Fahrenheit there over Greenland. And what about Antarctica? Yowzers, that is negative 71.3 degrees Fahrenheit. That is on the cool side. Anyway, to be complete, let's look at the hottest part of the planet. Looks like it's in Western Africa, perhaps there, pushing 100 degrees. The eastern coast of Africa there, over 100 degrees. Anyway, you may notice that we don't cherry-pick data about solar activity or earthly activity. We just cover facts, and we like to cover the science that includes predictive value here at the Smash News Network, least busted name in news. We don't cite any propaganda, fraud, or nonsense, and perhaps that's why the channel is largely not promoted by the junkware platform known as YouTube. Anyway, let's switch to the surface winds. These are the surface wind conditions of the eastern world. There's a funky wind ridge here in the extreme western Pacific there off the coast of Japan. Check it out. It's a weird wind ridge. You've got strong winds, and you've got calm winds, and then you've got other strong winds in opposition to them. That is kind of strange. That's an area where you're on your boat, and then all of a sudden it's calm, and then all of a sudden it's windy in the opposite direction. How you like them apples? Anyway, that's what's going on the surface. Here are the jet stream scenarios for the eastern world. Tripled up jet stream there over East Asia. Here are the jet streams over the Americas. Surface winds depicted here. And there are the surface winds of the central world, Europe, Africa, and the Middle East. Here are the jet streams. And let's take a look at the clouds and fog scenario over the Americas. So there is our clouds and fog view. The NASA GOES Interactive Weather Satellite Suite. If you want to view clouds and fog yourself at nighttime, use the 3.9 nanometer shortwave radiation map. It'll help you see the aurora. If you're not familiar with whether or not it's going to be cloudy over your location, this will give you a good idea. Continuing on to our weather.gov map. Hard freeze warnings over large portions of the southeastern U.S. continue. We've scrolled down to show you the key. There are too many locations on that map for us to cover. If your location is lit, click your location. Gale warnings there up the east coast of the U.S. also. Weather.gov is the location, and let's do some forecasts. So we've got some heavy winds here on the east coast. Those should move out. And then some heavy winds over the northern eastern coast. Also the Gulf seeing some high winds, and the Great Lakes seeing some high winds. That is the mean sea level pressure in millibars and the 10-meter wind. It's based on the GFS model for the next 72 hours. You've got time and date stamps in the upper left if you weren't aware. And here is your pressure and this is your temperature anomaly forecast based on the same model. That's temperature anomaly in degrees Celsius based on the GFS 72-hour model. And here is your pressure and precipitation forecast based on the same time frame and model, 72-hour GFS. We show 3-day forecasts because they tend to be accurate, like most of our channel's forecasts. Although we do think it is cute when channels that have 1,000 times as many subscribers leave ridiculous comments about grand solar minima. I think it's fun. I think it's hilarious. And we punch up to distant galaxies. Here's your windy.com map, and we're looking at precipitation type. Why? Because, well, check this out. We got snow in southern Texas and in Mexico. So that's always interesting, but watch this. New snow for the next 3 days. Some significant snow there forecasted for Mexico. That's a GFS model, and there's the Euro model for snow over the next 3 days. And indeed, there's about a 100% likelihood that snow will befall Mexico. And by the way, it's only less than 3 days from spring, folks. It's March 18th today. Apparently, Mexico is so hot that it's cold, although the southern portion of the country is actually hot. I can tell just by looking at the jet stream. So here's our NASA GOES lightning mapper, and there's an incredible lightning storm currently going on over the Gulf of Mexico. This is to the point where you might actually have good surf at places like Tampa Bay and Clearwater, Florida. So break out your wetsuits and surfboards, perhaps, as that is a major thunderstorm. Let's see if it's still going on. I think it is. That's our real-time lightning map from lightningmaps.org. And yowzers, that is quite an active couple of cells there. At least 2 or 3 separate cells likely to be going on there. The Gulf of Mexico, lighten up with lightning. All right, continuing on, we don't want the video to be too long. Here is your Doppler radar for the full 50 states. Quick reminder, the Ides of March have just passed when it looked like an engineered market crash occurred. Yeah, an engineered market crash. Why would crypto, stock, bonds, currencies, and precious metals and other commodities all sell off on the same day? An institutional sabotage of all financial markets. March 15th, 2020. Don't forget the day. Don't forget the hacks who've made terrible decisions and destroyed the planet's economy over the past 3 years. Accountability always comes, even if it seems impossible. So this is our final segments of the video. Don't forget to press like and subscribe and share, as YouTube does a pathetic job of recommending the most comprehensive space weather videos and most detailed imagery of the sun you'll find in the known universe. Anyway, this is your recap. That's U.S. Doppler radar. It shows vertical motion in the air column from ground-based radar systems. Here is our space-based satellite system showing clouds and fog at 3.9 nanometer infrared radiation. And don't forget the water vapor map. It shows all the water vapor. And you can see there's a huge pressure gradient forming here as dry, massive air forces its way toward Florida, colliding with this relative low pressure zone. So that's what's going on. Hopefully that clarified some things about the weather on space and Earth. Thanks for tuning into the Smash News Network, least busted name in news. If you're wondering what the hat is made of, there is no tinfoil involved. Anyway, we'll see you soon. And in the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Also, don't forget to visit the links here and here and here.